Hello, welcome to today's lesson, the law of reflection and plane mirrors. Reflection. The law of reflection states that an incident wave or particle will reflect at the same angle that it hit a barrier. Regular reflection, which occurs in mirrors and other smooth objects, is when all rays of the beam of light are reflected at the same angle. Diffuse reflection, which is much more common, occurs when the rays in a beam of light are scattered off a surface. Reflex reflection happens when incident light is reflected back the way it came. A plane mirror is a flat mirror. When drawing rays, we must always know a normal so we can measure the angle of incidence or reflection, and arrows to show which way the rays are traveling. So in this diagram here, we have our normal, which is perpendicular to our mirror. Okay, and we have our rays. And because of these little arrows, I know which way the light is traveling. Okay, and the angle of incidence and the angle of reflection are measured from the normal line. A normal line is simply a line that is perpendicular to another line or object. In the case of mirrors, a normal line always exists at the point of incidence, or where the light hits the mirror. Likewise, an angle of reflection is the angle between the normal, the angle of incidence is the angle between the normal and the incident ray, not the mirror, not this way. Likewise, the angle of reflection is the angle between the normal and the reflected ray, not the mirror. When we locate the image of an object in a mirror, we use a ray diagram, which are close approximations to numerical solutions. We will later do the math and get theoretical solutions. Describing images. The images formed in plane mirrors appear behind the mirror. This means that a light appears to be coming from behind the mirror. We call images in this fashion virtual images. A virtual image is an image that light cannot pass through, but only appears to pass through. When we describe images, we describe them with 4 characteristics. Their magnification, if they're smaller or larger than the object. Their orientation, if they're upside down or right side up compared to the object. The type, if it's real or virtual. And the position, if the image is closer, further, or at the same distance from the mirror as the object. And you'll need to remember these 4 as you'll be describing different objects in different kinds of mirrors. Locating and seeing images. To locate images in a plane mirror, we simply need to measure the object's perpendicular distance from the mirror. The image will be the same perpendicular distance away from the mirror, but behind it. It is very important to realize that for an eye to see something, light must travel directly from the something. So if an eye is to see an image, then light must travel directly from or appear to be coming directly from the image. To draw the light rays from an image, we must first draw a sight line from the image to the eye. This ray will turn out to be the reflected ray. If this straight line does not go through the mirror, then the eye cannot see the image. All lines on the back side of the mirror must be dashed because they don't actually exist. They just appear to exist. All lines in front of the mirror must be solid because the light came from something real. Once your first line is drawn, you must decide where the reflected ray came from. In other words, you must find the incident ray. The incident ray will always come from the same part of the object that the reflected rays come from. Finally, arrows must be shown. All right, so we'll go step by step through how to draw these. So first, you draw the image of the object. Use the principle that the object distance is equal to the image distance to determine the exact location. So you would measure between here and here, perfectly perpendicular with the mirror. Pick one extreme on the object and carefully measure the distance from this extreme point to the mirror. So usually pick the end to the mirror. Mark off the same distance on the opposite side of the mirror and mark the image of this extreme point. Repeat the process for all extremes on the object until you have determined the complete location of the shape of the image. Note that all distance measurements should be made by measuring along a segment that is perpendicular to the mirror. Okay, so in this diagram, they've measured from both ends, and carefully drawn the object on the other side of the mirror. Pick one extreme of the object and draw a reflecting ray that is traveling to the eye as its sights at this point. Okay, so this is my little diagram at an eye. Okay, the light ray is going to be coming to the eye, dotted on one side and solid on the real side. Use the line of sight as the eye must sight along a line at the image of the object in order to see the image of the object. It is customary to draw a bold line for a reflected ray from the mirror to the eye, and a dashed line as an extension of the reflected ray. The dashed line extends behind the mirror to the location of the image point. The reflected ray should have an arrowhead upon it to indicate the direction that the light is traveling. The arrowhead should point towards the eye since the light is traveling from the mirror to the eye, thus enabling the eye to see the image. Draw the incident ray for the light traveling from the object to the corresponding extreme of the object to the mirror. The incident ray reflects at the mirror's surface according to the law of reflection. But rather than measuring angles, you can merely draw an incident ray from the extreme of the object to the point of the surface on the mirror's surface, the point of incidence on the mirror surface. Since you drew the reflected ray in step 2, the point of incidence has already been determined. The point of incidence is merely the point where the line of sight intersects the mirror. Thus, drawn the incident ray from the extreme point to the point of incidence. Once more, be sure to draw an arrowhead upon the ray to indicate the direction of travel. The arrowhead should be pointing towards the mirror since light travels from the object to the mirror. Repeat steps 2 and 3 for all extremities on the object. After completing 2 steps, steps 2 and 3, you will only show how light travels from a single extreme on the object to the mirror, and finally to the eye. You will also have to show how light travels from other extremes on the object to the eye. This is merely a matter of repeating steps 2 and 3 for each individual extreme. Once repeated for each extreme, your ray diagram is complete. So let's just do a quick example of how to draw a ray diagram of an object. So I'll start with my mirror. And a mirror is usually drawn with slashed lines on the virtual side of the mirror. So I'm going to have an object So let's draw this object angled. And then I have an eye. looking at my object. So I will measure this distance and I will draw that point the same distance away on the virtual side of my mirror. Okay, and I'll do that for both extremes on the image. And once I have that, I'm able to draw my image as best I can. Okay, then we're going to look and we're going to see how this eye is seeing this image. So the first angle, or this is the incidence ray of the light bouncing, and remember we need dashed lines on the virtual side of the mirror. So this is the light reflecting to the eye. Then we can draw the light reflecting from the image to the mirror by just putting my ruler and lining my ruler up between this point and this point. Then I can draw this line of incidence to my eye. Okay, and same thing with this. Okay, so this ray's running that way, and that ray's running that way. And that's how you draw a ray diagram. We'll do another example in class. Please let me know if you have any questions. Have a great night.